Hi, and welcome to another video on object-oriented programming in C#. With me, Marinas Toman. Okay, so in this video we're going to talk about inheritance and abstraction. So these are two very important concepts in object-oriented programming, and you will see why, hopefully by the end of the video, you'll understand why these are so important. So what is inheritance? It's possible in C# to inherit fields and methods from one class to another. So in this tutorial here, they group the inheritance concept into two categories, which is a derived class. So that's a class that inherits from another class. We'll sometimes call that the child class. And then the base class is, or sometimes known as the parent class. This is the class that's being inherited from. So to inherit a class in C#, we use this symbol, just the colon. But before we go any further into the tutorial, we'll go over to Microsoft and see what they say. So inheritance, together with encapsulation and polymorphism, that's something we'll look at next week, is one of the three primary characteristics of object-oriented programming. So inheritance enables you to create new classes that reuse, extend and modify the behavior defined in other classes. The class whose members are inherited is called the base class, so that's our parent class. And the class that inherits those members is called the derived class, or the child class. A derived class can have only one direct base class, so a child can only have one parent. However, inheritance is transitive, so basically if I have a class structure where class C is derived from class B and class B is derived from class A, so class A is the parent, class B is the child of class A, and class C is the child of class B, then class C gets everything from class B and A. So basically all of the methods and properties, all of the members inside class A, class C gets them inherited as well. So conceptually, when we're talking about this, when we look at designing our systems, especially with class diagrams, conceptually what we want to think about is a derived class is a specialization of a base class. So, for example, if you have a base class animal, you might have one derived class that is named mammal and another derived class that is named reptile. A reptile is an animal and a reptile is an animal. So each derived class represents different specializations of the base class. So another example, could be your base class would be shape, and a derived class might be triangle. Another derived class from shape might be square. Another derived class from shape might be circle. So the class shape itself won't actually, the base class, the parent class, may not have enough information to actually create an object from it because it's just so generic. And then as we get lower in our class structure, so as we go down the levels, we want to become more specialized. So basically a simple way of looking or thinking of that is we want to add more methods or more properties as we in our derived classes, in our child classes. So as we kind of go down the hierarchy. Okay, so go back over here. So basically, if you remember when we were talking about class diagrams, we could see that we can inherit, so we can have parent classes and then we can have children classes. And this is, in a nutshell, what inheritance is. So we basically just, and that's sometimes why people refer to them as parent and child. You'll probably hear me calling them that more often than not, because a child inherits everything from its parent. And that's a good way to remember, the difference between the classes. So a child class If a parent has a property, let's say name, then a child is going to get that same property name. So we'll look at an example here. In this example, the car class is the child, and it inherits from inherits its fields and methods, or all of its members, from the vehicle class. So this is the vehicle class, this is our parent class, and as you can see, pretty simple. Just has two members in here, one public property, or sorry, public field, and then a public method. So then if we look at the car class, the colon shows that we are extending, or we're inheriting from the vehicle class. And then what we're doing in the car class is we just have a public field, public string field. So you can see here there's two members in the vehicle and there's one member in the car, but remembering that you can only see one member in here, but because this extends vehicle, you're basically getting another, you're getting these in here. These are here even though you don't see them. You have access to these, to this code, because you're inheriting everything, so you're getting all of this stuff for free inside the car class. So if we went into a different program, a tester program, where we wanted to test this new class car, we would create an object of car, and then we could perform honk. So we could use this honk method in the vehicle class, and that would be perfectly okay because a car is a vehicle. And this is the relationship that we're going to be talking, you're going to hear this a lot. The inheritance relationship, it's a is a relationship. So a car is a vehicle, a square is a shape, and that's always going to be the relationship. It's always going to be this specific class is a type of the generic class or the base class. Okay, so you can run this example and see that yeah, it does work. We look at the different, so that's the vehicle class, this is our car, and we're saying here what is the brand and the model name. So we're getting access to the brand is in here, is in the vehicle class. The model name is in the car class, but because the car is a vehicle, it gets access, it gets these methods and properties and fields all for free. They're all inherited, so it gets, even before there's a line of code written in the in this car class, as soon as you do extends from vehicle, you get all of that vehicle class code for free. So why and when to use inheritance? So really it's useful for code reusability. So we can reuse fields and methods of an existing class when you create a new class. And also when we look at polymorphism next week, we will see how this really can become more powerful. But for now we can just the new thing that we're learning really is this is how we can extend, or this is how we can inherit from a more generic class. And then of course we can start to look at the different relationships between our classes then. So as you can see, a car is a vehicle. So if this was in a class diagram, the car would have a solid line with a hollow point pointing up to the vehicle class. And it would be lower in the hierarchy. So if there's a way that you can stop other classes inheriting from a class that you write, and this is just by using the sealed keyword. So if you say sealed class, then anybody tries to basically extend your class, they can't. So that's just kind of, we're not going to be using that too much because we want to, learn about inheritance, and we want to extend classes and play around with things. So this is more of a security thing, but you should be aware of it, that anytime you see, in a class declaration, this sealed keyword, that, okay, I can't extend this class. So you can go and have a look, at what Microsoft themselves say, and again, they just, show you a more comprehensive example here. So you can see they use this base class work item, which has a good few members in it, and its own constructors and all of that. And then this change request, which extends work item. And then you can see down here what you need to do is basically when you're creating the constructor, you need that's the only thing that you don't get a copy of, is the constructors. Okay, so when you're inheriting from a class, you have to create your own constructor. Okay, so let's say, for example, in this example, we have a time span, a type that's of a type of a class, or even the string is a type of a class. So we would need to set that object up. Okay, so you can work away at that and read, and they're showing you examples here and everything, and read kind of what that's all about. So that's basically inheritance. Another thing I kind of wanted to share in this video just was some of these concepts now are going to get a bit more complex, and they're going to take a while for you to really understand and to kind of get your head around. So what I would always advise you to do is, everybody's different, everybody's got different ways of learning. So some people like reading, some people like watching videos, some people, I think with this stuff, what it really is practice. You need to practice. But with some of these concepts, just the kind of the concepts themselves, conceptually, they're hard to get your head around sometimes. So what I like to do is, there's this, some of these chatbots. Now, I'm not saying, go over and to everything that they say is absolute gospel, because, they're known to be prone to errors. But if you're looking for, a kind of a you can start to have a conversation with this thing and tell it, look, give me a simpler explanation, and you can start to actually glean, some nice simple explanations about these concepts. So I just want to go through something that I got off, it's Google Bard. So they're Google's new chatbot that is free. So I asked what are the main concepts in OOP, and it came back with these 4 main concepts. And then I just asked, give me an explanation with an example as well. So encapsulation, we've talked about that before when we were, looking at classes and objects, how we can encapsulate things, properties and methods inside classes, and then that means that we can, so when we're encapsulating, for example, our fields, we want to make them private, and then we can basically bundle all of that stuff into one place, or one class, one piece of code that has certain properties, has certain state, has certain behavior. But encapsulation, as it says here, is the bundling of data and methods into a single unit called an object. This allows the data to be hidden from the outside world and only accessible through the methods of the object. This helps to protect the data from being modified in an unintended way. So that's a pretty good answer. That's what we're trying to do. We're trying to encapsulate, as it says, we're trying to hide things. So I always like to use the analogy of the envelope. So there's some things that we want to show on the envelope. That might be like our method signatures. This is how you use this envelope, or this is where this is the address that I want this sent to. But there's some things then that you want to be able to seal that envelope up. You want to hide things in there. You don't want your data or your behavior or anything like that to be accessible from outside. So an example could be that you could have a class called bank account that has two attributes, balance and interest rate, and two methods, deposit and withdraw. The balance and the interest rate attributes would be private, which means they cannot be accessed directly from outside the bank account class, and the deposit and withdraw methods will be public, which means they can be accessed. Okay, so that's, we've seen that in previous weeks when we were doing classes and objects. That's really encapsulation in a nutshell right there. So abstraction, we'll look at that in the next video, but we'll just go down to, so what is inheritance? Inheritance is the ability of one object to inherit the attributes and methods of another object. This allows you to create new classes that are based on existing classes without having to rewrite all of the code from scratch. So you can see how, inheritance is really going to save us time, because we're getting a lot of code for free written for us. So you can write code in one class, and then it can be in one parent class or one base class, and then it can be extended into 20 different classes. So that there saves you writing 20 different properties and methods in 20 different classes. So that's a big saving, especially when your systems start getting a lot bigger than just the kind of simple examples that we've been going through. That you'll see that these systems become very large and very complex. So an example of inheritance could be that you could have a class called animal with attributes such as name, age and species, and methods such as speak and move. You could then create a subclass called dog that inherits all of the attributes and methods of animal, but also has its own unique attributes and methods such as bark and wag tail. Okay, so the dog class inherits all of the members, the attributes and methods from the animal class. The dog class also has its own unique bark and wag tail attributes and methods. So you basically get everything from the animal class for free. So we can see how this is going to be good for code reusability, especially to save us time when we're trying to reuse fields, reuse methods from an existing class into a new class. Okay, so that's everything for the video. Thanks for watching.